One thing that this chapter brings in, it asks, well, how do you recognize faults when you're looking at strata? And here's a road cut, and we can see this outcropping right here. And clearly there's a fracture going through here. Well, how do I know whether that's a fault or a joint? And the first thing we look for displacement. That's one of the first things to look for. Look for this offset, which indicates slip, which tells us we have a fault. And here clearly you can see that the strata, there's some offset beds in here that indicate slip. We can get up here really closely and we want to look for some other features like fault breccia. So because there's movement on here, the rock along the fault plane will fracture into these angular fragments. Remember, breccia is a sedimentary rock which has angular fragments, sharp edges. And so that means it's immature and it hasn't gone anywhere because it's still sitting in this fault plane. So fault breccia is fractured angular rock in the fault plane. Or sometimes it could be fault gouge, and gouge is milled powdered rock, clay size, very fine mud size. And so because there's movement here, the rock gets ground into a fine powder, and you get this fine gouge that forms along the fault line. And then other features we look for are fault scarps, right? So if you see a displacement here, remember in earthquakes, the presence of a fault scarp indicates young Holocene fault. So fault scarp here in Nevada here. So we look for scarps as well. And then for the Slickensides, I think there's a picture here. Yeah, so Slickensides are these striations, these grooves that are left along the fault plane as the two sides of the fault are grinding past each other. So there's a couple things going on here. We get the Slickensides, but also the rock is really fine and powdered here. That would be the fault gouge, that milled rock here. And then also in this picture here, we see these angular fragments. Well, that'd be the fault breccia, right? So we're looking for a variety of features to help us identify whether we have a joint or a fault. Summary here, remember stress, it's tectonic. Compression, tension, shear causes the rocks to change shape. Well, that would be the strain, right? So the strain is a reaction to the stress, right? So remember we talked about brittle deformation or brittle strain and ductile strain, right? Now, strain is a measure of how much the shape has changed. And the brittle structures we talked about are joints, joints that are filled with minerals called veins, and these faults. Now looking at folds, so folds are bends in geologic strata, bends in geologic units. So here is a pretty interesting image showing these pretty spectacular folds, and then showing an unconformity here. In fact, this would be an angular unconformity because here's some younger sediments are just lying on top of these folded strata. Now, when we look at the geometry of a fold, we're going to have something called an axial plane. And it's very important. A plane, it's a planar feature. And the key thing about the axial plane connects all of the hinge lines of a fold. And you can think of the hinge line as the inflection point. So the inflection point would be, note that these strata on the left here, this limb, the arms of the fold are called limbs. So over here on this limb, the strata are inclined or dipping toward the west, if we make this side the west. But as we go to the top, it's horizontal here, then these limbs are dipping toward the east, to the right. So it's a change in dip direction makes the hinge line. And you can see here we have 1, 2, 3, 4 geologic strata here in the fold. And these individual beds are folded, right? And each one will have its own hinge line. So this one's hinge line is here. There would be a hinge line that goes through here, or underneath here, then another hinge line back over here. So what the axial plane does, it connects all of these hinge lines, right? So the hinge line is one line. The plane is basically bisects the fold. Now, there are a couple of types of folds. There's one called an anticline, and the other one's called a syncline. And there could be different forms. It could be plunging anticlines or symmetrical anticlines. But for this case, let's just call the anticline an upward arching fold, right? An arching fold. But one of the key things about anticlines is that there is an age connotation. And note that here we have the axial plane. And note that the older strata, so that we know that this unit, based on the principle of superposition, is older than this unit with the gray units going through here, right? So this is older, this is younger. And note that the older unit will always be closer to the axial plane. So that's one definition you should know. For anticlines, the older geologic strata will be closer to the axial plane. As we go farther away on the limbs of the fold, the strata gets younger. So these strata are younger than the ones at the middle. So for anticlines, older strata near the middle, axial plane, younger strata farther away. The other thing that we want to point out here is there are no strike and dip symbols here, but the strike, one thing about strike will always parallel the contacts between geologic strata. So here's a contact between these two units. And so this contact here, so the strike would be going in this direction. And then note that the dip over here would be dipping toward the west, the left side here. But here, the strike would be right here, dipping toward the east. So note that for the anticline, the strike and dip symbols, all, or at least for the dip direction, all points away from the axial plane, away from the axial plane. Then for syncline, you can think of this as a trough-like U-shaped fold, right? Trough-like U-shaped fold. This would have an axial plane coming right through here. There would be hinge lines going right through here as well, hinge lines. And so here's the hinge line, and there's the trough-like fold. Now, with our definition, like we did with anticlines, for the syncline, note that the younger units are closer to the axial plane, and as you go farther away, the strata get older. So, for example, we know this unit is older than these because it's underneath. So older units will be farther away from the axial plane. Older units farther away from the axial plane, younger units adjacent to the axial plane. And if you think about strike and dip symbols, remember the strike line will parallel the contacts between the geologic beds. And so here, the strike would be this direction, but the dip would be toward the axial plane. So that's one thing about synclines, is that the dip direction is toward the axial plane. In fact, that's what these arrows indicate here. If we go back to the anticline, note that the dip direction is pointing away. So dip direction points away from the axial plane for anticlines. Dip direction points toward. In fact, this symbol, this line is really a geologic symbol we use on maps to indicate synclines. And then this symbol with the arrows pointing away from the axial plane is for anticlines. And we'll do more of that in a little bit here. Now, a special type of fold is where there's only one limb, right? And that type of fold is called a monocline. And monoclines usually occur over deeper set faults. For example, here's some strata that may have covered an older fault that was reactivated, and you can see as this older fault reactivates, it doesn't fracture the surface rocks, but the surface rocks bend along that older fault. And so we call that a monocline, where there's only one fold limb. So folds are described by the geometry of the hinge, right? So I mentioned earlier the symmetrical folds. So symmetrical folds have the hinge lines that are horizontal. So symmetrical folds have hinge lines that are horizontal, whereas plunging folds have hinge lines that are not horizontal. They're dipping, right? They're plunging is the word we use. So unfortunately, this diagram, the second one doesn't show that there's an axial plane. Just like this one, there's one that goes right through here, an axial plane, and all the hinge lines that go through here will be will be inclined from the horizontal. This one's horizontal, so this is a symmetrical anticline. This is a plunging anticline. So when we look at this picture here, for a plunging fold, we see, well, one of the easiest way to recognize that we have a plunging fold is that we'll see the fold on Earth's surface or on the geologic map. I see it right here. And then the other thing I look for the ages of rocks. And later on, I'm going to talk about this rule called the rule of V for geologic contacts. And you'll see that there's these V's that form right here. And the V's that form at geologic contacts, the V's always point in the direction of dip. The V's point in the, so here's another V right here, which means that on this side, because the V's are pointing off toward the left here, I know that these strata are dipping off toward the left. So if I could draw a strike and dip symbol, I would draw a strike line that's going this way, parallel to the contacts, and a dip going off toward the left here. On this side, same idea. I'd draw the strike line here, but the dip going off to the right. So here I see right away that I'm going to have an axial plane going through here, and then I have the strata dipping away from the axial plane, which means I must have an anticline, right? And they show the anticline right here. And then the other thing is it looks like it's plunging toward us, toward the front of the picture, because remember, this is by definition on an anticline, the older strata are always in the middle, right, closest to the axial plane. So here I have younger strata, which are younger than these, so that must mean that these must dip underneath these, right? So there must be a plunge that comes down in this direction, and that's what they show here. They show the plunge going underneath here, right? So these older units are cropping out down here, right? So there's our symbol for the anticline, and then we use this arrow to indicate that it's, say, a plunging anticline. So going back here, note that on this one, to complete this figure, I'd have to put an arrow here to show that it's plunging, right? That's what this is missing. When the fold is not plunging, there are no plunge arrows. And then other features that we see are these things called structural domes and structural basins, and they resemble anticlines and synclines, except they have these bullseye appearances, right? And so the key thing about a structural dome, it's like an anticline. The older strata are going to be in the middle. As you go farther away on the peripheries of the structural dome, it gets younger, farther away, older in the middle. If I could draw strike and dip symbols here, all the strike and dip symbols, well, the strike would be parallel to the contact, but the dip would be away. Strike parallel to the contact, dip away. So all the dip would be away from a central portion. For the structural basin, note that the younger strata is in the middle, and as you go farther away, it gets older. And note I have a strike line here dipping toward the middle, strike line here dipping toward the middle, strike. So all the strike and dip symbols would be dipping toward the central point, indicating a structural basin. Now, your book mentions this idea of how folds develop. And there's two general ways. One is called flexural slip, and that can happen in not very deep levels in the crust. And all it means is that there is this slip that occurs between geologic strata. Note that there's slip to accommodate. So the other important part of flexural slip is that the thickness of the individual beds does not change. The thickness remains the same. And in order to keep that same thickness, you get a flexural slip between adjacent sedimentary beds, adjacent stratums or strata here, right? So there's slippage going on here between these. This one slipped up, this one slipped down to accommodate this anticline right here. So you can sort of see this idea, this flexural slip going on here. For passive flow, here we need some heat. So this is probably occurring deeper down where we're seeing we're seeing that ductile deformation. And the key thing here is note that the thickness of the units change, right? There's thinning of the limbs or thickening of the limbs, right? So there's a change. Remember, in the flexural slip, there's no change in thickness, but in this passive flow deformation or folding, we do see the change in thickness. And the other part is each point we see here will travel different directions, right? Each marker point will travel different directions, giving the bed now, thicker or thinner appearances here, right? So that occurs again where you have more heat flow, ductile deformation.